So based on the name, can you figure out what could be an ambidentate ligand? Like we've come across ambi quite a few times, Pele.
Yes. Is it something like it can have like that its density can be 2, but then still it chooses to be like sharing only 1 or something like that?
Yes. Yeah. So its density is only 1, but it has that one thing it can link. It has multiple atoms that it can link from. Yeah. Like it can form only one bond, but that one bond can be formed with any atom. So basically, yeah, a ligand that has 2 different donor atoms and either one of them, not both, any one, either one of the 2 ligates in the complex. Okay, any one of them. So, for example, nitro group. So, if you remember nucleophilic substitution made, you have ambivalent nucleophiles, right? Is it called ambivalent? So basically, like suppose you have a cyanide atom, Cn minus. Either it can form a bond from carbon side or from the nitrogen side, right? That sort of a thing. So same thing over here also. Cyanide is an example, is made. Nitro is also another example. So how do I give? Yeah. So suppose we have nitro group. It can link with the nitrogen from the nitrogen atom, or it can link from the oxygen also. So nitro is an example.
But what will be the specific factor for that? Like, how will we know?
You come across it. I mean, like this also, this is a type of ligand that exists. So usually, like either there's usually a hint in either the nomenclature. Like for example, cyanide may have either cyanide or isocyanide. That way, for there is going to be a difference in the naming or in writing, like the representation. When you write it down, that differentiates between these. Thiocyanate is another example. Either it can dentate or link from the sulfur side, SCN. Cyanide is CN, so thiocyanate is SCN. Thio usually stands for sulfur. So if you come across thio anywhere, it means there's a sulfur in that compound. Or the nitrogen can link to it. So it's not a different molecule. Like SCN, the order of how the molecule is formed, all of this is the same. But only thing is, where is the metal atom? Like, is it towards nitrogen side or is it towards sulfur side? Like, that's the only thing that's different in this case. This is thiocyanate. And cyanide is another. Either it links to the carbon or it links to the nitrogen. So just, for your, like we won't come across this a lot when we come, like we'll mostly look at cyanide, you won't come across NC, you won't nitro and all. It's rarely ever given in terms of nomenclature and all. So you don't have to worry, but you just know that, okay, this is something that exists. So know a couple of examples in case you're asked a question based on that. Then few more. The next term we need to know is coordination number. We've already discussed a little bit about this. What is the coordination number? Do you remember?
The secondary valency.
Huh. Now that you know about ligands and coordination entity and all of that, can you put it in better words?
The number of ligands attached to the center atom.
Number of donor atoms. Because remember, it can be a polydentate ligand. In that case, ligand is one, but the number of donor atoms that it is bonded to can be multiple. Right? So coordination number, you look at it from the point of view of the metal atom. Okay, how many bonds am I having with either one or multiple ligands? That. So this is the number of donor atoms or ligand donor atoms, call it that. To which a metal is directly bonded. इसमें like to figure out the coordination number, you need to know in advance whether it's unidentate, bidentate, tetradentate, hexadentate. Because based on that only you'll be able to figure out. Okay. So if we look at some familiar examples, platinum hexachloride or hexachloroplatinate as it should be called. So iska coordination number will be equal to how much?
6.
Yes. Okay. Next one, Sanskriti needs to tell me.
Yes, ma'am.
Iska coordination number will be?
Ma'am, is it 12?
5, 12.
Ma'am, is it 12?
Why 12? Why do you think 12?
Ma'am, because NH, it's NH3K, there are 4. Achha, sorry. It would be 4.
4.
Because HK3, okay, 4.
Yeah. H doesn't care. H is just there with nitrogen. Nitrogen is the main one that's bonded to nickel, and how many of that is there? 4 of them are there. So, okay. Next one. This is a good one. Oxalate. FeC2O4 taken thrice. 3 minus. So I'll tell you what the ligand is, okay, because you might be unfamiliar with it. So C2O4 2 minus is oxalate, and iska structure is like oxalic acid ka anion. Okay. So based on this, can you tell me coordination number kya ho sakta hai?
6.
6 is correct. Because every oxalate, like every unit of C2O4 has 2 places it can bond to. It's a didentate ligand. And there are 3 of them. So 2 into 3, 6. So totally it forms 6 bonds with iron. Okay. Kind of looks like this. Iron is at the center and octahedral shape hoga, but like in to represent it in 2D. So यहाँ पे C double bond. So here one CO this thing, and यहाँ पे एक और CO. Obviously it's like bonded to oxygen, but yeah. So this kind of what it looks like. So didentate 3 units. Total you can see that iron has 6 linkages. Next, CO, En taken thrice 3 plus. इसमें कोबाल्ट का कोऑर्डिनेशन नंबर क्या है? En is ethylene diamine. Ethylene diamine, we've just looked at it. So you don't remember, like flip the page, figure out कितना होगा. Sanskriti, tell me. En is short for ethylene diamine. So ethylene diamine is ethylene 2 carbon atoms and 2 amine groups. Okay, so based on this, Sanskriti coordination number क्या होगा?
Ma'am, is it B? Not sure.
Like अभी discuss किया हमने. This is not a new thing. Ethylene diamine में how many points? How many donor atoms are there? How many points is this?
Ma'am, 2 donor atoms are there.
हाँ, so 2 are there. That way En के 3 है इसमें. So total coordination number like how much would it be?
Okay, so it will be 6, right?
6, yes. Okay. Similar to oxalate, just that it's a different compound. Okay. Okay. So another thing, like you have not come across this abhi tak, but you won't come across 5 bonds. It's not at this like 12 standard level. But generally speaking, coordination number matlab you count only the sigma bonds. So it is literally how many atoms is this particular metal atom, like central atom bonded. So whether it's more or pi, like okay, how many total linkages are there? That's the kind of idea you need to get out of this. That's why you count it. In case there's like a pi overlap. Okay, and then we have coordination sphere. So coordination sphere is that, like suppose we have this central atom AX, BY. So this particular part that's enclosed by the square bracket, this particular part is the coordination sphere. The coordination sphere is central atom plus ligands, which is enclosed in the square bracket.
Same as entity, right?
Yeah. Okay, so formula may like what statement sentences may sometimes if they refer to okay, this is the coordination sphere, you just need to take this into consideration. It may or may not have other external items, but we are not talking. Then we have three more. That's it. Almost. Sanskriti done.
Yes, ma'am.
So then we have coordination polyhedra. Okay. Coordination sphere, we're talking about it when you write it as a formula. Polyhedron is we're directly talking about that molecule. Like, so this references the spatial arrangement that is of the ligand atoms. So it's directly attached to the metal central atom. So this is that tetrahedron, octahedron that we talked about. This is referencing the actual 3D structure of that coordination entity. So this one is again quite important. Oxidation number. So we had already studied about oxidation number pehle. You guys remember the concept around it? So this is the actual charge carried by the central atom or ion. Like if it carries a charge, call it an ion, otherwise it's an atom. By the central atom or ion. If all the ligands are removed, with the electron pair shared. So oxidation number is important. It is represented by Roman numerals in brackets. This is carried over to your normal salts also. Like you come across iron 2 oxide, iron 3 oxide, right? So it's telling you, okay, what is the charge present on iron over there. So generally, like, okay, what this means is like in words, if I write it as iron oxide. So I'm saying that iron has a +2 charge. The charge carried by it is 2. So then you can figure out the formula is Fe. So even like when we do the nomenclature, that's what is coming up. You have to mention the oxidation number of the central atom based on that. Okay. Another reason why this is important is you may be asked, like nomenclature may you need to calculate the oxidation number. Even otherwise, you may be just given a coordination compound, like some complex compound, and you'll be asked, okay, what is the oxidation number on cobalt in this? That sort of questions also can come. Okay, we'll do a couple just to practice, just to get it. We'll pick a thing from here. Pick a simple one. Suppose we have this Ni NH3 taken 4 times 2 plus. Isme, can you figure out what is the oxidation number on Ni? It is very similar to how you generally calculate oxidation number in any like given compound. Okay. Are you guys giving it a try, or should we do one together first?
+2.
Okay, how did you get +2?
Like ammonia is a neutral, so it does not have any. So if you take x of Ni, then x plus 0 is equal to +2.
Yes. So overall charge of this whole thing is 2 plus hona chahiye. Matlab, whatever species are inside, adding all of this, total you should get 2 plus. So Ni ka pata nahi na hame. So if we take that to be x, we have 4 ammonia molecules. Ammonia is neutral. So 4 into 0 should be +2. So x will be equal to +2. Okay, so oxidation number on nickel will be +2. Similarly, can you guys calculate oxidation number on platinum in this? So just send it on chat, like I want answers from both of you. Okay, Smira has already calculated it. Yes, that is correct. Sanskriti, what are you doing? Oxidation number calculate nahi kiya?
Ma'am, how did you figure out कि उस वाले में n का वो 0 होगा?
Because ammonia, we know it's a molecule, na? Like you would be aware of ligands. OH minus, matlab OH में -1 charge है. वैसे you are like all these are simple molecules that you know of. तो यहाँ पे Cl6, Cl usually independent atoms में तो नहीं होगा ना, because Cl is very reactive. So Cl usually exists as chloride ions. So chloride पे charge कितना होगा?
-1.
Correct. So use that. So there are 6 chlorides. हर एक पे -1 है. Overall -2 होना चाहिए. So in order to get -2, platinum पे कितना होना चाहिए?
Okay. Ma'am, is it 4?
Plus or
Oh,
minus?
sorry. एक minute. Sorry. +4.
Plus or minus?
Ma'am, +4.
Plus. Yes, +4 is correct. So every time you are asked about oxidation number, no, whatever context it may be, always that plus minus should be there, because it literally represents what is the charge carried by the central atom. Agar 0 hai, then you don't need to put plus or minus because 0 is 0. But if you get any number, it's not a maths wala number. It talks about the charge. So you need to write it as +2, -2. Like -2, so yeah, you will do it. But if it is positive, mention the plus there. Okay. Okay, so that's oxidation number. We'll have a lot more practice in this when we do nomenclature. And the final term, this is homoleptic complex. So homo, again, this gives you a hint what we might be talking about. means something is same, something is uniform, right? So homoleptic complex is when the central atom is, or in the complex, if you have the central atoms bound to only one type of ligand. Yeah. अभी तक whatever examples I've taken have all been homoleptic complexes, but yeah, इसका opposite, when you have different types of ligands, homo का opposite, you get heteroleptic complexes. If you have multiple ligands within that coordination sphere, then it comes under heteroleptic. It's bound to multiple complexes. Sorry, multiple ligands. Sorry, not complexes. So homoleptic का example अभी तक जो भी complex लिया हमने, all of them are homoleptic. Another example, yeah, take any CO, NH3 taken 6 times 3 plus. Hetero का अभी तक हमने examples नहीं देखा. So CO, NH3 taken 4 times Cl2 plus. Like in this case, you have two different ligands. You have ammonia also, you have chloro also. So because there's two different ligands within the same coordination complex, comes under heteroleptic. When you have only one ligand bonded to the central, this thing comes under homoleptic. It's just different types. Okay. So like let's be more like elaborate on this. Instead of saying multiple ligands, say multiple types of ligands. यहाँ पे 6 ligands, all of them happen to be the same one type of ligand is homo. If you have different atoms, molecules here, heteroleptic. Cool. So this is the main thing. Homoleptic, heteroleptic, unidentate, bidentate, all of these are different types. The main terms you'll keep using are ligands. It'll keep coming up again and again. Oxidation number you have to know, and coordination number, because based on, if you know the coordination number, you can figure out what is the shape you're going to get out of it. Yeah, so these are like the main things. Okay. Nomenclature. Okay. How much do you remember about IUPAC organic compounds का nomenclature?
Like basic, longest carbon chain has to be taken.
Steps है ना multiple. So even coordination compounds, because you can see that they are complex compounds, like pretty complicated, multiple atoms and all of them are there. So these also have a specific format to name them. Here. So before I talk about the rules of nomenclature, can you guys write down, like, let me see if, which is a comprehensive thing. So I'll give you guys a table, just may you're given examples of different ligands and you'll be given the IUPAC nomenclature may what short form it has and how it should be named. So make that table, write it down once so that at least you'll have a point of reference there. And then we'll talk about the rules and then it'll be easy to practice nomenclature uske baad. Okay. Nomenclature rules. Okay, I'll end the session here and I'll share with you guys like a table of, if I have like a whole list of ligands along with the name that you need to use for this thing. Just organic may we have like meth, eth, prop, but, and then functional groups ka bhi specific names hai na. That way, is maybe you have a specific format and a specific name. Like metal atoms is pretty straightforward. Jiska symbol hai, that is the name. You'll call it ferro, you call it cobalt, you call it nickel. But ligands ka name is not what you usually use. Like you won't use it as ammonia every time. And then you have some new ligands you haven't come across, like EDTA, ethylene diamine, oxalate, and all of that. So I'll give you guys a list so that you have that list of names, you're familiar with it. Note down the table somewhere, and once you've finished writing it, ping on the group, then we'll resume the session. Okay. Cool. I'll just send it to you guys in a minute once I have that table. Okay. All right.